Hi everyone, my name is Frédéric Passeron and welcome to this HPE DevTalk, which will be the 31st DevTalk. So the subject that will be covered hopefully today by Sam, if he shows up, is Smartsim and bringing simulation and AI together at scale. So the speaker will be Sam's party from Cray R&D. And he showed up a moment ago, but disappeared. So we'll give it some time while I'll be presenting to actually come back, hopefully. So for those who don't know yet what the DevTalks are about, maybe it should be interesting for you to reach out to some of the links that we'll be providing to. So before the talk starts, I mean, I'll go through a very few housekeeping items, being the calendar, for instance. So if you reach out to the URL that one of my colleagues is gently pasting in the chat, you will see that there are many DevTalks that have been already delivered over the past. I mean, we've been there for a year now. And so for each of them, you get the register link or you get the replay as well if you were not able to attend to them. The next session will be held on the 21st of July, and it will be talking about recovering important cloud-native application in the fast-paced DevOps world by Prashantho Koshavara. And also, we're planning a few stuff for August, even though some of us will be on vacation. Some of us will also be working, so stay tuned on this. I know that Didier is preparing something around Kubernetes and some other cool stuff, I would say. As part of the HPE Dev program, we also need your help, okay? So, I mean, I'm leading the workshops on demand, I would say, program. And so it's available on the following workshop URL here, and you will see there are around 20 of them, and we keep adding them on a monthly basis. So it's free hands experience, it's free of charge, it's available 24/7, as long as the data center is up and running, I would say. There are some surveys that you can fill up at the end of each of the workshop. We lately introduced some badge program, and we'll be very happy to get you some badges for any workshop that you will be finishing, I would say. And if you finish more than one and you go to 5 or 7 or 10 or 15, you'll get some wonderful badges they can share over some social media like Twitter or LinkedIn, for instance. You can also contribute and win a wonderful background, as Tina is thinking about. So you can do some blogs, okay? Write some technical blogs about the technology or the subject that you are mastering, okay? You can work with us on some dev talks and obviously be able to spread out some of the cool things that you have learned about the technology or experience that you have shared with a customer, for instance. Speaking of which, you can actually invite your customers to our Mention Learn. So Mention Learn are similar things to the DevTalks, where DevTalks are internal. The Mention Learn are widely open, meaning that you can invite your customer to attend them. The next one will be taking place on July 28th, and it will be around how to make data consumable for real-world data sets. And there is another one for August on Kubernetes 101, and it will be hands-on based as well. So you can check out the Mention Learn agenda on the URL. And also, very importantly, there is a survey that we would like you to take into account, which is a /data developer survey. And you can invite your customer actually to go for it as well. It takes a bit of time, but it's really important for HPE to actually take an image of what people think when it comes down to HPE and developer. It's not necessarily the first, I would say, couple that you would think about, but we're trying to change this. So it's really important that we get some data around this. And finally, please communicate. I mean, the dev program and the dev team is only probably less than 10 people. And we'll try to shout out. And as you can see, my voice is getting tired of shouting probably. And so we really need you to help us out in this way. So you can use the chat, the Yammer groups, or you can use the Slack channels, or you can use Twitter. And there is one single slide that we know about and that we would like you to use. And I'll be sharing it at the very end, but this is the one that we want you to use. Okay?
Awesome. Great. So my name is Matt Ellis. I'm one of the members of the Smartsim team. And I'm just going to give a quick overview of what Smartsim is, what it does, and what we hope to do in the future a little bit. So with that, I'll just jump right in. So Smartsim is an open source library dedicated to accelerating the convergence of AI, analytics, and data science with numerical simulations models. This is particularly interesting and challenging because historically numerical simulation models that are run on HPC platforms are traditionally written in C, Fortran, and C++, while the data science ecosystem is really Pythonic, right? It's written in dynamically typed languages. And to date, those haven't really been super compatible or really merged together. And Smartsim is really meant to bring those two ecosystems together. So very specifically, Smartsim enables scientists to embed machine learning components into Fortran, C, and C++ simulations. So with very little changes to your HPC code, you can now embed and run machine learning models directly from the simulation. Also in real time online, you can run and monitor those simulations from a Jupyter notebook. Also, you can run your entire workflow from a single Python script, which I think unless you've actually tried to run these very complex simulations with machine learning on the side, you might not kind of get how impressive or hard that is. But that's something that we've seen as we talk to users that they really love, that now their entire workflow is in a single Python script that is actually very portable between the machines as well. We can create and configure ensembles of simulations for the users. And I guess just if you're not familiar what an ensemble is for a scientific application, a lot of times you'll do parametric studies and you'll want to just run maybe, I don't know, hundreds of a simulation with one parameter change. And Smartsim just makes that very easy to do. And moreover, because of the architectural choices that we've made, it's very easy to plug in tools like Dask, Xarray, PySpark into this Smartsim framework to do either data extraction or analysis. And I think most importantly from a performance standpoint is that all of this bypasses the file system. So there's a lot of approaches that might do pieces of what I just mentioned, but they usually touch the file system. And of course, that makes it very hard to scale to very large simulations. So one of the key features of Smartsim is that it's really truly an in-transit in-memory framework. So that's just a very high level. I'm just going to keep diving deeper. Feel free to interrupt with questions. But that's just kind of a quick overview of what I'll talk about. So let's dive a little bit more into what actually makes up Smartsim in terms of the code base. So Smartsim is kind of split into two libraries. The one set or the one library is the Smart Redis clients, and these Redis clients are what gets actually embedded into your application. So the core client is written in C++, and then we have wrappers on that core client in Fortran, C, and Python. So across all of these languages, we have very coherent APIs, and that is what actually gets embedded by the user into their application. The second library, which is the infrastructure library, and sometimes we'll just call it Smartsim, but it's really the infrastructure library, is what allows users to launch and manage these very complex machine learning scientific application workflows. And what the infrastructure library does is it basically abstracts a lot of the nitty-gritty details you would need to know about your particular system or workload manager, and allows you to launch what is the infrastructure that is required to run machine learning alongside these scientific applications. And that infrastructure library really just presents a very simple and clean Python interface to the user. So they don't have to write a lot of bash scripts or anything like that, which quite frankly, I used to do before we had Smartsim. So it just makes things very clean and easy for the users. So here's the architectural overview of Smartsim and how it works. Again, there's two libraries, and you'll see those designated in blue and green here. We have the infrastructure library and the Smart Redis library. The infrastructure library, users access through either a Jupyter notebook or a standard Python script. And on the left here, you see highlighted in yellow. And they use that just through a very simple from Smartsim import experiment. It's super lightweight. And through that API, they build what we call an experiment. And those experiments contain entities such as a scientific application or an orchestrator, as you see here on the right, which is our name for what allows them to store data, run scripts, or run AI models. And I'll get a little bit more into the details of what the orchestrator is and does in a little bit. But those are the two main entities that we think about when we launch things from Smartsim. And as I said, Smartsim on the top left here kind of sits between the user and their typical workload manager like Slurm, EBS, Cobalt, or even on a laptop, you can launch all of this. So the user doesn't need to know how to do specific resource management work to launch the orchestrator or an entity onto the machine. To put this in more like concrete details of what we're actually doing with the Smartsim infrastructure library, and also to talk a little bit about that orchestrator that I just kind of glossed over. So again, Smartsim, there's a Python interface. It sits between the user and their workload manager. And what it does is, and for this example, just think of a typical molecular dynamics scientific application. And this is really just a pure MPI application. So, before Smartsim, before, the ability to run machine learning alongside the simulation, it would have just been, an MPI simulation across multiple compute nodes. And Smartsim still does that for the user. So if Smartsim, you did not want to run machine learning alongside this application, that's fine. We can still really make it much easier for you to launch this on any high performance computing platform and still kind of do the same MPI resource allocations that you would do before. But the beauty of Smartsim is that it also allows the user to very easily, and by easily I mean like 2 commands, launch a Smartsim orchestrator alongside that traditional MPI application. So the orchestrator is what we call kind of the centralized location for both the data and where we can run both Python scripts and machine learning models. So that orchestrator can live on separate compute nodes so that it has all of the resources on the compute nodes, or on certain workload managers, it can actually be co-located with the simulation. In this diagram that I have here, it's just shown as a separate compute node for simplicity, but note that it can share the resources on a compute node with an application. So the Smartsim orchestrator, again, is a in-memory database. So just think of a key value store. So when you put things into the database, it's basically just accessed with a key, like a Python dictionary. So if you say, get my key, it'll return the value. You just need one key value to access the data in the in-memory database. That is a Redis database, and Redis is a great open source in-memory database. It has a really rich ecosystems of tools. And one of the great things about the Redis database is there's a Redis module that allows us to give users access to TensorFlow, PyTorch, and Onyx. And when we give users access to these machine learning backends with a single API call from their scientific application, they can run these machine learning backends on the hardware, the compute hardware in the orchestrator with a single call. And I'll get into what the API looks like in a little bit. But it's a really quick and seamless way for the user without much adaptations to their original source code to have access to these machine learning backends. And these backends run both on a CPU or a GPU. So lots of flexibility there for the user. And then I guess I should point out that the application, in this case, the molecular dynamics simulation, communicates with that orchestrator over TCP. So again, just those very simple client functions that we've written allow the application to communicate back and forth with the orchestrator. And I just went over that, so I'll just skip forward. I mentioned the API of Smart Redis. So one of the things that we've tried really hard to do is just across all 4 languages, Fortran, C, Python, and C++, first to have a very coherent API such that it allows scientists to kind of develop and share their work in one language and port that to another one. So that was really important to us. But another thing that we learned from kind of seeing other kind of data storage tools that we worked with before that couldn't even do the machine learning side, but just the data storage side, is the APIs were just so heavy. The users had to actually put in quite a bit of code into their application just to do the very simplest of tasks, right? So the other thing that we really try to do is just keep the API very simple. So you'll see here on this slide, these are all the calls that the user would potentially need to put a tensor in the database. So any n-dimensional tensor from a compiled or Python application, run a machine learning model on the back end. So to put the model into the database and to run the model, or to run any PyTorch script. So put a PyTorch script in the database and run that script. So here we have a total of 9 API calls that allow any application in those languages to put tensors in the database and then do data processing and machine learning model inference on that database. So when we say it's lightweight, it is truly lightweight. We've put this in applications in the matter of, like, I don't know, hours. And the big hurdle is learning about their application, not ours. We have like 9 lines of code. It's just really easy for users to get set up. And then on top of those basic functions, which I should mention, these are all the data structures, the tensor, the model, the script that Redis kind of requires to use those machine learning backends. On top of that, we offer to the users what we call a data set. The data set just allows users to group together tensors and metadata to preserve contextual relationships between them. So very common in a scientific application, you would just group all of this information together in some kind of output file that's written to disk. The data set kind of allows users to do that output file type data storage, but to do it in the in-memory database. And the great thing about this is that you can access that group of tensors or metadata with a single key, right? So you don't have to remember a lot of keys. You just say, you know, client.get data set and then a single key value, and you get all of your information back. Again, this API is very lightweight. There's only 9 functions here that you need to use to construct, store, or inspect a data set. And another great backend feature of the data set, which the user only sees through performance gains, is that the data set allows us to do a lot of manipulation on the back end to preserve the data locality. And that gives us a lot of efficiency gains for model inference and PyTorch script runs. So I think I might stop there for right now and just ask if there's any questions on the overview of Smartsim and the API and how it works. There's got to be some kind of question. I went so quickly and glossed over things. There must be something.
So far. but feel free to unmute yourself if you want to and speak up. I mean, the more interactive, the better the session is, I would say.
Okay, if there's no questions, I might just kind of dive into one of the use cases that we've already done to show kind of the full features and power of Smartsim, if the audience is interested. And is Alessandro Ragazzi on the call?
Yeah, I'm here.
Okay, great. Al, I might punt to you as we get into this, since you did a lot of the machine learning work. Great.
Okay.
So one of our first kind of big test cases for Smartsim was a collaboration with the National Center for Atmospheric Research. They do a lot of climate modeling and oceanographic work. And they have this tool called MOM6. And MOM6 is an old, and I say old only because it has a rich legacy of development that spans many years. It's still currently being developed. But it's been around for a long time. And it's written in Fortran. And they wanted to do some machine learning work to replace a parameterization inside of MOM6 to both hopefully improve runtime, but also more importantly, improve accuracy. So they really wanted to replace what is, when you see the results, you'll see that it's actually a pretty coarse and bad parameterization within MOM6. So this was a great use case for Smartsim because as MOM6 is written in Fortran, their hands were kind of tied into how do we get modern data science tools into that application. And the people who had the knowledge base to accomplish the science work in terms of the ocean modeling honestly weren't machine learning experts. So they didn't have the background or the resources to learn how to spin up all the infrastructure that they needed to run this kind of pretty complex ensemble on a supercomputer. So this was like the perfect test case for Smartsim to see if it worked. And it was a great success for us, and they've been great evangelists for us since then because it was such a big help for them. So the goal of this project, as I said, was to augment MOM6 with what is the mean eddy kinetic energy parameterization using a machine learning model. The augmented simulation is the modular ocean model. We'll just call it MOM6. The training data was just a super high resolution run of MOM6, what we call it was MOM6. You use 1/10 degree simulation. So we call that the ground truth. That is like a absurdly high resolution ocean model that you could never run in production. It's just too expensive. And then the simulation that our machine learning model got put into was an ocean model with also a sea ice model. The model that we used was a modified version of ResNet, what we call EKI ResNet, eddy kinetic energy ResNet. And the inference was done on, so this work was originally done on an internal machine where it had 16 compute nodes, each with an NVIDIA GPU. And MOM6 used up over 3,000 ranks on traditional CPU compute nodes. This brings up a good point that I didn't highlight when I talked about the capabilities of Smart Redis and what it does with machine learning models for you. So I should just mention that a lot of times these Smartsim orchestrators, actually most of the time, they span multiple compute nodes. So you can use anywhere from 1 to thousands of compute nodes to host the data and the machine learning model. And one of the great things about our client, which you won't find in any other open source Redis clients, is that it smartly distributes a copy of the machine learning model or PyTorch script to every compute node, so that you can very efficiently do massively parallel evaluations of that machine learning model. And so in this case, for the MOM6 work, they used the smart clients to do that. So we were doing massively parallel inference across all of those compute nodes. Al, with that, I think I'm going to hand it off to you because I think you could probably explain this work the most. Just let me know when you'd like to advance the slide.
Okay, thank you. Yeah, so you can start the video, I think. And here you see the predicted EQ values. And these are the values we predicted in real time, basically, while the simulation was running with our neural network, so EQ-ResNet. So basically, the great thing about this was that the results we were computing with the neural network were then fed back into the simulation, and they were used for the next time step. And one of our concerns was obviously that we didn't know if simulation could have exploded or could have gone to zero. Instead, we were very happy in seeing that all the patterns we would expect, like those at the equator and those in the south, the western boundary currents and so on, those are all reproduced by our neural network. And this was basically our first assessment of the goodness of our approach. We can move to, I guess, next slide. And here you see we compare our results to the previous state of the art. So the previous state of the art was trying to use simply mathematics and physics models to compute these adiabatic energy value. And you see it in the low picture. So, and what you see is basically that at the equator, it misses all the features. And the truth data, so basically our ground truth is the data we obtain on the 1/10 of degree model, has a completely different structure that our model, our Smartsim enhanced simulation, is more capable of reproducing. If you look at the right-hand side in the top image, you will see that at the equator we can see the activity, and the same in the south of the southern hemisphere, we see the activities, and the levels are much more comparable to the ground truth than those we observed in the previous state of the art. We can go to next slide. And yeah, we actually also ran a different workload. So once we managed to run and simulate the 10 years, I think, 1 year at the beginning, but so the whole simulation without problems, and we saw the results, we decided to go for something like a uncertainty quantification. So basically we ran an ensemble of simulations. So instead of one single simulations, we ran 12 at the same time, each one running on 19 nodes of a Cray XC. And we ran it for 10 years of simulation time. What this means is that basically 12 copies of the simulation all started with just slightly different initial conditions, ran at the same time, all communicating with the same Redis cluster, running inference with the same neural networks. So different copies of the same neural network. And the good thing about this was not only that we could observe some uncertainty and so some statistical value in our simulation and our ensemble, but also that the slowdown was negligible. So it was like below 6% compared to the state of the art. And so basically it's a price you're willing to pay for these kind of results. And we wrote a paper about which also includes this, and I posted the link to the paper in the chat, and you also find it on the HPE Dev portal. At the end of the article, you will see all the links. And I think we can go to next slide, unless Matt, you want to add something.
No, that was great, Al.
Okay.
Really great.
And
Okay,
yeah,
actually, Al, I lied. I was going to say one thing. So I think one of the things I also forgot to mention about Smartsim and Smart Redis is that when you do really complex ensembles like this, Smartsim actually takes care of preventing key collisions for you. So there's no adaptation that you need to do to each of these ensemble member source codes to get this to run. Smartsim actually very kind of seamlessly under the hood takes care of all of the key manipulations to make sure that none of these collide. And so all of these are running exactly the same source code except for input file changes. Sorry, Al, I just forgot to say that.
no, that's important. Yeah, it's really 12 copies of the same executable, and that's also something which is very, very easy to implement them in the pipeline. Yeah, current research topic, just we are integrating Ray into Smartsim. So Ray is a work distribution library, and it supports a wide ecosystem of applications. The most important ones are RLlib, which is like the state-of-the-art reinforcement learning toolkit for distributed reinforcement learning. Basically, it's compatible with the state-of-the-art and OpenAI's environment for reinforcement learning, and Ray SGD, which is distributed deep learning training. Plus, it has HPO and all those great libraries which run then on distributed on any system. And we have implemented and integrated this into Smartsim, and it will be available in one of the next releases. We can go to the next slide.
I think that might. Yeah.
You can. Yeah,
I'll let
you finish the presentation.
Oh, I mean, yeah. Sorry, Al. I just thought that was the last slide.
Go ahead.
So you know the talk a little bit better than I do. So here's some links, and we can post these in the chat as well. But this is where you can just find some more about Smartsim, and where you can watch for updates on Smartsim. We are hosted currently on PyPy, which means two great things. One, you can just pip install Smartsim, which is just a super easy way to get started. But another great thing about that is you can just kind of stay up to date with our releases without having to track us on GitHub. But please send us any Slacks or emails if you have any questions, and we'd love to take your questions right now as well.
No question.
Then one other thing to note, I know someone put it in the chat. We do have, I did talk to Sam about I'm not sure if he's having technical difficulties or what's the issue at the moment, but I do know that he has Jupyter Notebooks had put together for today. So we will make that available for folks. That can be more of a hands-on tutorial.
Yeah, I'll be planning to actually add them to our workshop on demand. So
yeah, that'd be great.
The plan, so that they are available to all year long to anyone. So, and as Dennis mentioned, we also created a platform page actually on our website for the Smartsim resources. So you'll be able to find them on our HPE developer.com website as well. It's brand new because I know that Dennis and Sam did work on this yesterday, and probably that Dennis made it available just today. I think.
It's actually Ben who provided the platform content, and I published it just a few hours ago.
Okay.
The next step will be nice, Matt or Ben, to think about a blog post that we could tie to the platform that would show data scientists and developers how to leverage Smartsim.
Yes.
This would be a really great blog post. And
so there is a question about how to estimate the additional computational cost of Smartsim in our model. Can you read it from Adam?
Yeah, so that is a very case-by-case thing to look for. I think they might be referring to what Al said in the MOM6 use case where we had about 5 to 6% overhead for using Smartsim. And that is just pure wall clock time that we measured, which includes all data network traffic, but also all of the calls to actually run the PyTorch models. So that includes the runtime of the machine learning model. So that's not just kind of Smartsim data transport.
Okay, thanks. Yeah, I figured it was case by case. I didn't quite know how to ask the question.
Yeah, it's really hard to generalize just because I mean, we've seen it in follow-on use cases, kind of everybody has a different use for Smartsim. And it's really hard to give guidance. Like a lot of use cases are super data heavy, and a lot of use cases are like, hey, I only have one tensor, but I want to run this giant model. So it's kind of hard to generalize that for a talk like this. That being said, I'd be confident to go out on a limb enough to say that the excess runtime, really, you don't see it in like the data transport through Smartsim. You tend to just see it in like the pure time that it takes to run a machine learning model. That's kind of like what you tend to run up against here. So the clients themselves that move all the data and the models and execute the commands are actually pretty quick and lightweight.
Okay, that's good to know that it's sort of the basic infrastructure is rather lightweight, is what you're saying. Whatever bells and whistles you want on top of that to do that really determines the additional cost.
Yeah, good question though. Great question.
We also have a repo which is called Smartsim-scaling, where we host some tests for scaling Smartsim on different node configurations, both for simulation and database size. And that could also give, let's say, some hints about the performances. So one could start working on that instead of like using already the simulation, the targeted simulation.
So this is Dale Rensing. I'm part of the HP Dev team. And I have a question actually for the participants, if that's all right.
Oh, yeah, sure.
Okay.
Yeah, please.
So I'm interested in knowing why the folks who registered for this particular talk. What brought you here? Has it met your needs? Are there specific things, more information that you're looking for? Should we bring them back to talk about more?
I brought up a poll just in case that we usually do at the end of the session. So that's what you wanted me to bring up. So here you are.
Well, that's part of it, but I'm looking for a little bit more interaction from people to just give me a good sense. I help people get blogs out there. So if there's more information that you're looking for, this would be a good time to say, I would like to read a blog about this particular topic.
And feel free to use the chat to answer, or just speak up and mute yourself and provide some comments, please.
This is Balvinder.
Yeah, go ahead.
Yeah, I'm from Pacific Northwest National Lab, and I was like, what brought me here is like I'm working on a model, and I'm not getting enough time to get really started with Smartsim, but I was really interested in this idea. So I was working with Sam, and he got me started, and then I got busy with other things. But my plan is to get back to that and work on the model which I was working on. So we already used a tool which we are not very happy with at the moment, and Smartsim sounds like a good way to go. So that's what I wanted to learn more about it and see if I can use it in my application.
Curious what other tool you use, just to understand the broader market.
We use FKB.
Oh yeah, yeah,
Fortran Kira bridge.
yeah.
So
Definitely.
like it works great. It was really easy to get started off. It is a simple library. You just build it and use it. And but I think Smartsim offers much more. So I just wanted to explore like what it has to offer and how does it compare with the FKB bridge. Yeah, so that was my motivation.
Yeah, no, and I mean, I think I can kind of answer that a little bit. I mean, I think with the Fortran Keras bridge, you know, like you said, I think it's, if you just want to kind of integrate an AI model that's already trained, that, you know, you kind of have, that's a little more static, you know, that is definitely something that you can use. I think from a capability perspective, the advantages that Smartsim as a kind of more of a machine learning data science framework offers is not only can you add in models, but at the same time, you can do online analysis, you can do visualizations, you can do like steering, like if you're running a bunch of ensembles, you can do steering, like computational steering. So it really allows for a lot more flexibility, because what we focused on, the kind of the core component that we focused on was more about the data exchange and how to, you know, how to kind of step outside of that MPI pair, that traditional paradigm of communication, and how can we use, you know, just pass over single tensor, and then what are all the things you could do with it in memory and at scale. And, you know, the other thing, I think the other advantage that, you know, the Smartsim framework offers over the Fortran Keras bridge is the FKB is really pretty what's the word, a little bit fragile in the sense that it's, you know, the two have to align. So if there's any updates in terms of, if there's any updates to Keras, you know, you've got to update the library, right? So it's a little fragile in that, or not necessarily as robust as we'd like it to be, or, you know, like as we like to see in applications. So I think those are kind of some of the main differences between the two things. Does that make sense?
Yeah. We also found it like limiting in the sense that whenever we wanted to do something new, we had to wait for somebody to implement that in FKB, or we had to do it ourselves. So that was a limitation. And I have another question. So now that HPC can be run on, like, clouds are more accessible to HPC applications. So I was just wondering if anybody has tried Smartsim HPC combination on clouds, or whether it would be beneficial, or is it more beneficial to run it on like regular traditional clusters?
Yeah, so it definitely worked. I mean, correct me if I'm wrong, Al, but we've definitely run Smartsim on cloud services before. And there really isn't any issue on there. And then the user experience is primarily the same, because Smartsim just abstracts away a lot of that kind of workload manager launching work. I haven't specifically done it, but I know Sam has run it on AWS, for example.
Okay.
Yeah, and if you have more questions about that, you know, feel free to join the Slack and ask us that. I mean, some of it comes down to, you know, resourcing costs, availability. You know, there's a lot of, I think there's a lot of factors there. But our goal overall is to allow people to move, you know, hopefully long term, be able to move between, you know, whatever computational scaling makes sense for your solution, in order to, you know, kind of provide these features and these capabilities, leveraging Smartsim, right? Because we understand that moving forward, you know, kind of the integration of simulations and AI is really going to mix, right? And those environments include cloud environments, right? It's not just it's not necessarily singularly an HPC problem. And so we want to make sure that we provide the flexibility to be able to run under all the contexts, you know, that makes sense for, you know, your kind of your computational needs. So.
Okay, thanks.
Yeah.
Any other questions?
And that's Jim wrote, cloud systems don't tend to scale as well as HPC, and models like Mom. Right. That's very true. And like I said, I think it depends on, definitely depends on the type of simulation you're running and the type of scale you're trying to run at. But one advantage, I guess one reason we'd like to be able to make sure that people could still use it in a cloud scenario is imagine if you're doing some sort of testing or model development and what you have accessible to you, or maybe the budget that you have at the moment is limited in the sense that, you know, you can't necessarily, or you don't necessarily have access to an HPC system. We want to be able to make sure that, you know, you can do the processing both and development both locally and on the cloud, and then move to HPC scale when appropriate, right? And that you have the same user experience, the same APIs, and the same capabilities, and just be able to execute at the scale you need.
Hello, this is Tina.
Hey, Tina.
Hey, so I know Dale asked why we were here. And so I just wanted to share why I'm here. Just Slack has been really good with allowing a lot of us to connect who would have never otherwise ever been able to connect. Yeah. I've always wanted to, you know, learn and be a part of the HPE developer community. So when I got a chance to see the Munch and Learns and just be here, I'm thoroughly excited. So I hope I'm not embarrassing myself, but I'm here because I want to be a part of the community and to learn from all of you, to connect with you, and to, you know, hopefully one day be completely engulfed in the community. And I'm just really excited. And if anybody here has anything to offer to help me along the path, and, you know, I'm studying Python, I'm new to Python, so I'm in a current process of studying Python. And, you know, just really, really elated that I was able to connect with the HPE developer community. So that's why I came. Thank you.
Yeah, no, and it's super awesome to have you here. And, you know, Fred's saying start with some of our workshops, and that's, you know, a fantastic idea, right? It's always in our group, especially around AI, you know, for our group, or especially around AI, learning is constant, right? So we're constantly in beginner mode and trying to figure out new tools and new frameworks and what people are using. And so getting what's great about this community is with the workshops, having some hands-on tutorials is a way to, you know, really continue to further your career and stay connected to all kind of the great, the wider tools that are out there, you know, the stuff that HPE has to offer, and kind of, you know, how those tendrils reach out into the wider development community. So that's awesome. And Fred posted it, an example for you for Python, if you want to check that out.
Yes, thank you. I'm very excited. Thank you so much.
Yeah, super glad you're here.
Welcome. And yeah, as Dale said, you can also work with us on some blogs and hopefully you'll get a chance to get our wonderful background. Okay, yes. So with that being said, if there's any more questions, please. I mean, we still have like 7 minutes left, so we can still post a few questions if needed. If not, then I can close the call. But please take time to fire up one last minute question if needed. If not, then I will leave it with the final slide that I'm just showing right now, showing you all the different assets that the HPE Dev community is providing you with, being the website, the Slack channels, the newsletter, contacting us through mails or Twitter, in the Yammer group or Slack, or the workshops on demand, and the other stuff like Dimension Learn and so on and so forth. So there's only one slide that you need to know about. This is the one, and please incorporate it in any type of customer interaction, I would say, at the end of your slide set. It's always interesting to show that there is a developer community program within HPE and that people should know about it. With that being said, I wish you a very good end of the day, and hopefully to see you soon on the 28th, if I remember well, for the next DevTalk, sorry. And otherwise, enjoy the end of your day, and thanks a lot for attending this workshop.
And I would like to thank you as well, Ben, Alessandro, and Matt, for this great presentation.
Yeah, and
the introduction of Smartsim.
Yeah, and if you get any news from Sam, we'll be very happy to know how is he. hopefully nothing wrong with him. And so have a good day, and you can stop the recording, and we can close the call right now.